Welcome to the last section in Algebra 2, section 14.1, which is about the sine and cosine graphs. We're going to spend the majority of the rest of the year studying sine and cosine graphs and how they apply to real life situations and problems. But to begin with, I'm going to take you back to the unit circle that we developed and created the last two videos. And specifically, I'm going to look at the values that are multiples of 45 degrees, which are the ones that I'm underlining in blue, because those are the ones that we are going to use just for the purpose of graphing today. All right. Now, what we want to do is we want to graph y equals sine theta. And hopefully you printed off the cheat sheet that I'm going to fast forward a slide here that looks like this, the graphs of the sine and cosine functions with a little chart down here at the bottom. Hopefully you've got this printed out because this is what we are going to use. But just like I've taught you all year long, we're going to make a t-table. T-table is going to have theta, which is really x, and that's in radians, and then the value of y. All right, well, if we go around the circles going in that direction, first of all, we have 0 radians, and obviously the cosine value is our the sine value is our second value, which is 0. Okay, now we're going to go 45 degrees. Now 45 degrees is pi over 4. We're going to use radians, pi over 4, and the value of that is the square root of 2 over 2. The sine value is square root of 2 over 2. Now if you type that in your calculator, the square root of 2 over 2, it's approximately 0.7071, which is the decimal that we are going to use, because I can't plot square roots on a number line. Next one, 90 degrees. That's pi over 2. 90 degrees, the sine of that value is 1. Now we're going to go to 135 degrees. That's 3 pi over 4. 3 pi over 4 is also square root of 2 over 2, which is about 0.7071 for the sine. And then we're going to go to 180 degrees, which is pi. All right, well, that value is 0. Very good. Now we're on the bottom part of the circle. 225 degrees is 5 pi over 4. Oops. 5 pi over 4. And the sine of that number is negative square root of 2 over 2, which is negative 0.7071. And then we're down here at 270. Now 270 is 3 pi over 2. 3 pi over 2. And its sine value is negative 1. And then we go to 315, which is 7 pi over 4. My board here is slightly off today, which the sine of that is negative square root of 2 over 2, or negative 0.7071. And then finally we're back to 360, which is 2 pi, and that's the same as 0, so the value is 0. Now what I want you to look carefully at is the y values. All year long I've tried to tell you that the y's are the shape of the graph. Obviously the y values go up to a height of 1, and then they go back down all the way to negative 1, and then they go back up to 0. There's a pattern there. It's symmetric, and that's going to be very important when we graph the sine function. So let's fast forward a slide. This table, if you copied your notes, great. I'm sorry. Otherwise, if you put it on the back side of your circle graph, on the back side of that, that's fine too. If you need to pause the video, go ahead and do so. All right, so now let's talk about graphing. We're going to graph both the sine and the cosine function. I'm going to do the sine in blue. So up at the top, here's my cheat sheet, my coding, my color coding. Sine of theta is going to be in blue. Now, what we need to do, let's go back a page. What we need to do, come on, go back a page. It's not going back a page. Well, what we need to do, people, oh, there we go. What we need to do is when you graph sine and cosine, there are 5 key values. The first one, the last one, the one halfway in between, the one halfway in between each of those. Those 5 values we need because those are the maximums and the minimums and the middles. Those are what we need. Now, going forward again, let's graph this. So we need 5 key points. So this will be, right here will be point number 1, point 2, point 3, point 4, and point 5 on our graph. That's where we're going to graph those. So obviously, here's 0, and when the sign, or when you have the angle 0, the value is 0. Now we need 5 key points. The last one is 2 pi. So that's going to go there. Now halfway is pi. Halfway from that is pi over 2. And now from there, now we're going to count when we number. 1 pi over 2, 2 pi over 2. This will be 3 pi over 2. This will be 4 pi over 2, or 2 pi. This is 5 pi over 2. This is 6 pi over 2, which will actually reduce to 3 pi. This is 7 pi over 2, and this is 8 pi over 2, or 4 pi. Now, if I plot my dots, at 2 pi we were at 0. At pi we were at 0. At pi over 2 we were at way up at 1, if you remember our table. And at 3 pi over 2 we were down at -1. Now also halfway in between, right here is going to be pi over 4. At that point we were about right here, which is 0.7071. And then right here, I believe, was 3 pi over 4, and that value was 0.7071. And then right here, I believe, was 5 pi over 4, and we were at -0.7071. This is just an estimate, these values right here. And then the last one right here, which was 7 pi over 4, we were at -0.7071. So if you follow my graph, hopefully this works on the smartboard, it's a nice smooth curve that first goes up, then goes down, and then finishes back at 0. Now obviously this same pattern is going to continue. So I'm going to draw a dotted line. At 5 pi over 2, if we wanted to continue, we'd be up there. At 3 pi, we'd be at 0. At 7 pi over 2, we'd be down at -1. And at 4 pi, we'd be back to 0. Now, I'm going to draw a dotted line here for a reason. And I want you to do the same. The graph goes on forever. Forever. Therefore, in the x direction, our domain would be all real numbers. The range, obviously the range is up and down. The lowest it gets is -1, and the highest it gets is +1. So therefore our range is all y values greater or equal to -1 and smaller than +1. That's our range. Okay, now we've established that. That's what the graph of the sine function looks like. Very, very important. So make sure you pause the video and copy that down exactly as it appears, and then we're going to talk about it. We're going to talk about some terminology. All right, here we go. Terminology. What you saw in the sine graph is an example of a periodic function. A periodic function is a function that repeats a pattern of y values over and over. Now you notice that's what's happening on our graph. Our graph, if I go back one, our graph repeats the numbers. From here to here is one full cycle, and then from here to here, the dotted line part is the second full cycle. Now what do I mean by cycles? That means repeated y values over and over. A cycle is one complete pattern, either in the graph or the y values. Okay, one complete cycle. So if I go back a slide, what I drew in red is one cycle. From 0 to 2 pi is one cycle. And then the dotted line would be the second cycle of this graph, because it repeats itself. So that's why I had you draw a solid line and then dotted line, so you could see the difference in the cycles. Now, period. Period is the horizontal length of one cycle. It's basically the x values. How far the x values go for one cycle. Now I'm going to go back and do a little color coding. Our solid line is one cycle. It starts at 0, and I'm going to shade this in green, so hopefully you can see it on the video, and it ends at 2 pi. One cycle, that's the horizontal length that's in green. That's its period. The period is from 0 to 2 pi, so the length of it, the period's length, is 2 pi, which you can fill in on your chart, which I'm going to go back here. The horizontal length of one cycle for the sine function is equal to 2 pi. That is the period. Now, the period can change, which you're going to see in the next video. But for right now, and for the basic sine graph, that green line is the period. Which brings us to amplitude. Amplitude is basically the y value. Amplitude measures the amount of change in the y values. And amplitude is always positive. Always. It's never a negative number. Okay? And the formula for amplitude that I want you to write down in black is maximum minus minimum divided by 2. That's how you figure out amplitude. Now I'm going to back a slide. Amplitude is going to be my black line. Amplitude is half of the total height. That black line right there is the amplitude. Okay? Which is basically max minus min. Well, the max is 1 minus negative 1, which is the minimum, divided by 2, which is equal to 2 over 2, which is equal to 1. So the amplitude of the sine function is 1 because it's half of the total height. Total height is 2. Amplitude is 1, which is half of it. And finally, frequency. Frequency is the number of cycles from 0 to 2 pi. Now, in the case of the sine function right now, the frequency is equal to 1 because there's only one cycle from 0 to 2 pi. Finally, the general form of the sine function is y equals a sine parenthesis b theta. Remember, theta is x. It's kind of like x right there. The amplitude is the a value, the absolute value of a, because it's always positive. That's the amplitude. The frequency is the b value. And the period will always be 2 pi divided by the absolute value of b. That's how you figure out what the period is. So that's where you get your 3 words from the general form of the sine function. Amplitude is a, frequency is b, and the period is 2 pi divided by b. That's the basics of the sine function graph, and in the next video we're going to do a number of examples to help you understand how period and amplitude can change and how the sine function works.